Hi students, very good evening. I think most of us are already here. So today we are into the second session. So second session of the first and important chapter in physics, which is the physical world, units and measurements. Okay. I think last class doubts irunda. I think one student was asking some doubt. Other than that, not many of you have asked any clarifications on what we covered in the last class. The doubt irunda, you can just even class mudinadukku appuram you can type it over there in the chat window in the concept digital. You can just post it, so we'll be able to provide the clarifications. Okay, so start pannalama. So we'll start with the session. First we look at what is the coverage of this chapter. Enna nama cover panna pora indha chapter la. So we are going to talk about the understanding of the physical quantities. Idhula da nam irukku ipo. Okay, so we are looking at what are different physical quantities, other units ennu solittu adha nama ipo cover pannit irukom. Adukaprom we will go and look at what is this dimensions concept and dimensional analysis. The previous class na sonna madiri, it's an important area for the NEET examination. Then we look at eppadi measurement edukkuradhu. I mean, how do we cover these measurement part of it with regard to the physical quantities. Based upon the measurement, right, we have the concept of error analysis. The measurement error eppadi varudanu solittu we will cover it when we go there, but this is the broad coverage. Okay, so in the error analysis and dimensions part, this is the important area for the questions in the NEET examination. Okay, but to know all these things, right, what is the basis? The basis is here, what we are doing in the last class and today's class, understanding of the physical quantities. So pay attention students, we'll continue from where we left in the last class. So last class we were looking at the idea of a unit. So unit anna ennadi, what is an unit? So unit is what? It is the base value of expressing a measurement. If distance between 2 points or 10 centimeters on sonna, what is this basically? There is a base value called as what? Centimeter. In the centimeter da nama base value on solitrukom. Okay, so base value is what? Centimeter. And this measurement is basically how many times? 10 times of that centimeter. Okay, so whenever we give any measurement, it will be always by using a base value, and the base value da nama unit, and that's what we are calling as the unit. Clear students? Now when we look at these units, right, last class itself I gave you the idea. We look at these units as either standard or non-standard. So how do we see these units? Standard unit, otherwise non-standard. What is the difference between these two? Okay, so standard and non-standard, what is the difference between a standard unit and non-standard unit? Okay, so standard unit means, maybe ninga note pannikala in the definition. What is the definition of a standard unit? Standard unit ennadi? Standard unit should be consistent. Adu consistent ah irukano. It should be reproducible. We should be able to reproduce. Okay, invariable and easily available for usage. Enna characteristics நம்ம இதுக்கு define பண்றது? We are defining some characteristics. Enna characteristics? Look at this. First, and now we are saying it must be consistent. Consistent ah irukano. Okay va? It must be reproducible. Reproducible means what? You are having a meter scale, and the meter scale which I can measure a tape exactly on the same length measure panni, I can also call it as what? 1 meter. It should be reproducible. Okay va? Invariable. It should be invariable. Variable and variable means what? If say for example the meter length is changing, 1990s meter is one value, today the meter value is changing, like that. Okay, so it is what? Variable. Appadi it should not be variable, it should be what? Invariable. Okay, and also it must be easily available for usage. Ipo unit number define panni it's not available for easy usage and there is no benefit of it, right? So whatever the units we are talking about must be easily available for the usage. Okay, at least most of the units. It is not like every unit is easily available for usage. So most of the units, right, must be easily available for the usage. And we are calling it as what? Standard unit. Okay, so standard unit we have like all these things, right? Centimeter or meter. Okay, I'm talking only about the units of distance, mile, kilometer, even for time, right? What are the units we have? We have second, hour, minute. These are all standard units. Okay, so they will be consistent. So other attributes they should be consistent. They should be what? Reproducible, and they should also be invariable and easily available for usage. Okay students, what is the other type of unit? Non-standard. Non-standard anadi, it will not satisfy these properties. What is a non-standard? It is not going to satisfy these properties. Okay, which means I'll just give you one simple example. Okay, so if you see what we are indicating here, generally we will say, right, arm's length and solluvaanga. Okay, so what is arm's length means? We'll measure the distance by using the arm. Correct? So we'll measure the distance by using the arm. So arm's length and sonna, is it a standard? Because you measure your arm's length, it will be different from your brother or sister's arm's length. It will be different from your father or mother's arm length, isn't it? So means what? It will change from person to person. So who is measuring it? It will change from person to person. Okay, wow. So we will not be calling it as what? Standard. Why? Because it is changing. So generally, right, if you look at these non-standard units, so generally if you look at the non-standard unit, how they will be? They will change from person to person. A non-standard unit, right, they will be changing from person to person, or they will change from place to place. Okay, or they will change from time to time. Okay, so they will either change with respect to person, or they will change with respect to place, or they will change with respect to time. Okay, wow. So all these are what? The non-standard. Like say for example, if you talk about the length of the day. Okay, so what is it? Length of the day. Length of the day anana theriyuma, it's also unit for time. Length of the day is basically from sunrise to sunset. Length of the day means what? From sunrise to sunset. Okay, now is it a standard unit? No. Why? Because we know in summer the length of the day will be longer, in winter it will be shorter. Even if you go to the polar region, North Pole and South Pole, if you go to polar region, right, the length of the day will be shorter. Like if you go to the polar places, right, there the length of the day sometimes may be just as small as 4 hours. Daytime will be 4 hours and night time will be what for them? 20 hours. Okay, so total 24 hours la, day will be only 4 hours, night time will be 20 hours. For us it will be generally what? Half and half, right? 12 hours day irukum, 12 hours night. For them it will be day will be shorter and night will be longer. So all these are what? So whatever which will change from person to person, or from place to place, or time to time, apdi change ana, then what do we call it as? We'll call them as what? Non-standard units. Clear students? Okay, now what we'll do is we'll just check how we are able to understand this concept of standard and non-standard by quickly looking at one example. Okay, so we look at an example, students. Look at this. Maybe you can type the answer in the chat box. So what is this question? Which of the following is a non-standard unit? So what all they have given? They have given us Kelvin, they have given us room temperature, they have given us degree centigrade, they have given us degree Fahrenheit. Adilla we have to find out which of them is a non-standard unit. Check it, students. What is our task here? We have to find out what is a non-standard unit. I am waiting. Maybe you can just type the answers over there in the chat window. Okay. So we have to tell which of them is a non-standard unit. So all these are what? All these are the units of temperature. All these are what, students? They are all the units of temperature. Okay. After some time we will see Kelvin and NN, we will see what is degree centigrade, what is degree Fahrenheit. We will cover all these things. But I think we already have some understanding about them. Yes or no? We already have some understanding about these things, right? I think some of you might be already knowing that Kelvin is what? Kelvin is the, okay, so I think we are able to get some responses. So which is the non-standard? So Subhasri and Rachel, you are saying it is what? Room temperature is non-standard. Why it is non-standard? Because the Kelvin or degree centigrade or degree Fahrenheit, okay. And remember one thing, students, we will not call the Kelvin as degree Kelvin. We will not call Kelvin as degree Kelvin. The degree will be only for the centigrade scale and then Fahrenheit scale. Kelvin scale degree varadu. Okay. So we will just call it as what? Kelvin. So we should not be putting it like this. Okay va? So it should be only just simply Kelvin. So if you look at room temperature, right? Generally when some medicine or something is given to us, right? What they will generally write in the back side of that is caution madri, they will write it. Okay. Store this at room temperature. Like that they will mention the conditions. But what do you mean by room temperature? Generally the temperature that our room in the daytime temperature is what we call as room temperature. But is it a standard unit? No, right? If you look at a country like India, maybe summer time the room temperature will be around 25 degrees and the madri irukum. Winter la pona it will be decreasing. But if you go to cold countries, right, the day temperature itself might be very different. Okay. So the room temperature will change from place to place. Room temperature for us in India is different from room temperature for people in UK or Switzerland. Okay, wow. So that why the room temperature, right, it is a non-standard. Others are all what? All the others are standard. Okay, students. So room temperature is what? Non-standard. Now even the standard units, right, like about distance nama measure pannumbodhu we have seen, like there is a centimeter, there is a millimeter, there is a meter, there is a kilometer, and there is a mile, there is a feet, there is a inch. Even for one physical quantity like length, we are having so many standard units. Yella standard units da. It is not like they are non-standard. And by the way, before we go into the discussion, I think I would have told you that whenever we are talking about the academic measurements or calculations, right, it is understood that we will not be using the non-standard. So we will not at all be referring to the non-standard. Standard mottunda we have to talk about. Okay. Now look at this. So when there are so many standard units for even one physical quantity, the question is why there are so many standard units. See, there are a lot of reasons. Like they say, right, one size doesn't fit all. Like you see a small boy, right, avangaloda buniyan size and this big, exercising fellow. So one size, right, doesn't fit all. So which means, look at it, if I want to measure distance between, the place where you're sitting to your living room or something. So the distance inside your house. How do you measure this? You will measure it in terms of maybe meters or feet. If you want to measure the length of the pen which you are using to write, or if you want to measure the length of your mobile phone screen or your laptop screen or your system screen, your tablet screen, what you will say? You will be talking in terms of inch or something like that. Okay, so or centimeter. Now if you want to discuss about the distance between your place to some other place, say railway station or bus depot or whatever it is, right, we'll try to express the value in terms of either kilometer or mile. So what I am trying to say is, ஒரே இது நம்ம எல்லாம் ஃபிட் பண்ண முடியாது. We cannot fit and use same unit for all these measurement. That's why there are so many units. That is one thing. Okay, so first is what? The usage. Second is there are also some historical reasons and even some geographical reasons. So like if you look at some countries, right, like generally if you talk about US, weight or mass, right, they will be talking in terms of pound, but in India we will generally express this in terms of what? Either grams or kilograms. Okay, so if you look at US, the distances, small distance means they will try to measure in terms of what? Feet. We will try to measure in terms of centimeters, like that. Okay, or meters. They will try to measure the longer distances in terms of mile, but whereas in India we will talk in terms of kilometer. Like if you see a bike or a vehicle in India, right, how they will give the speedometer, in the vehicle we will have the speed measuring device, right? How do you see that? You will see that it will be indicating kilometer per hour, like that. But there in US you will see that the vehicles will be marked as what? Miles per hour. So there are some historical and geographical reasons, and since all are standard units, right, people have been continuing with that as a convention. Okay, so there are so many standard units, and obviously when there are so many standard units, right, the next question is how do we relate them? Because if we are getting some data from US lende or data vandu vechukonga, then they are giving the mass all in terms of pound, and our experiment we are doing everything in terms of grams. So appo nama enna pananum, we have to convert that pound into gram. So means what? While we are talking about academic work or in general science, right, we will be required to convert the value of the measurement from one unit landu ingon unit. So like we have to convert the value of the measurement from one unit to another unit. So how do we go into convert is something that we will see. Okay, wow. So whenever there are so many standard units, right, one thing that we will be required to do is what? We must be able to convert the value of the measurement from one unit to another unit. Now when you look at these units, right, these units are put into some specific groups which we call as systems. These units are put into what? Some specific groups which we call as what? Systems. What are these systems? If you look at the three most popular systems, right, other than the SI. Okay, so SI system is developed based on the MKS system, and the SI system is developed. But the three most popular systems of units have got their names: FPS, CGS, ingonanadi MKS. They got their names based on the units of length, mass, time. So if fundamental quantities are there, right? How many fundamental quantities are there? 7 fundamental quantities are there, isn't it? How many are there? 7 fundamental quantities. So for these fundamental quantities, we select each of the fundamental quantity or standard unit choose panni, we will create it like one system, and that way these 3 popular systems have come. Today of course we are not going to use much about these systems, and we will mainly focus on what? SI system. But historically these 3 systems were popular before, as an standard everyone started following the SI system. So FPS system anadi, in this the unit of length is taken as foot. Okay, now I have seen some students asking a doubt. So what is the difference between foot and feet? Okay, so because when you talk in terms of the normal length measurement, they will say 10 foot or 5 foot, like that. When you talk in terms of area, they will say 20 square feet, like that. Okay, so don't worry too much about them. So basically foot is representing a singular, and feet represents what? Plural. Okay, so foot represents what? Singular, and feet represents plural. Now the FPS system is what? The length unit in the system will be what? Foot, and mass unit will be what? Pound, and time unit will be what? Second. That's why the name FPS has come. Okay, wow. And CGS and the length is what? The unit of length is centimeter, and the unit of mass is gram, adukku da g varudhu. Okay, c centimeter la c, gram la g, second s is coming here. Okay, then mks means what? Meter, kilogram, second. Meter la you are getting m, kilogram la you are getting k, second la you are getting s. Okay va? So that is how these three standard systems which were popular before the SI system has come. But once the SI system has come, right, now we mainly will be using only the SI system of units. Okay, so what is this SI system of units? So in the SI system, right, we will look at what are these fundamental physical quantities or units. What is the unit of length in SI system? Meter. What is the unit of mass? It is kilogram. What is the unit of time? Second. Maybe ninga idella note pannikala. Why? Because these things we must be very much thorough. We should not be forgetting about them. Okay. So what is the SI unit of electric current? It is ampere. What is the SI unit of temperature? Temperature we also call it as what? Thermodynamic temperature. Okay. So what is the SI unit of temperature? It is Kelvin. What is the SI unit of amount of substance? What is the SI unit of amount of substance? It is mole. MOLE. Okay. So what is the we will see that there will be a definition for each of these quantities, right? So meter and sonna adukku or definition irukum, kilogram and sonna adukku or definition irukum. For all these SI units we will have some proper definitions. Okay, the amount of substance, what is the SI unit? Mole. Luminous intensity, adoda SI unit enna? Candela. Okay, now since we use these SI units very often, like in a normal problem you take, right, sometimes we may have to use this word kilogram 10 times. We can't keep on writing kilogram like that for so many times. So that's the reason why we use these symbols. So what is the symbol for meter? Small m. What is the symbol for kilogram? Kg. What is symbol for second? S, small s. What is symbol for ampere? Capital A. What is symbol for Kelvin? Capital K. Okay. So generally the symbols that will come after the scientist names, ampere is a scientist name, Kelvin is a scientist name, they will be in the capital letters. Okay. What is the symbol for MOLE, MOL? The E mottum kattago. Okay. So what is symbol for the mole? MOL. Candela, what is symbol for candela? CD. Then we have plane angle and solid angle. Supplementary. So plane angle, what is the SI unit? It is not the degree. Generally, we will measure the angle in terms of degree, right? 30 degrees, 40 degrees, 45, 60, 90, apdi. Okay. So, but what is the SI unit of plane angle? It is radian. What is the symbol for that? RAD is the symbol for the SI unit of the plane angle. Okay. What is the solid angle of the SI unit? It is steradian. What is the solid angle SI unit? It is steradian. Okay. And what is the symbol for this? It is SR. Clear, students? So again I am telling you, all these SI units, right, they have clear definitions. Remember what we said? Whenever we talk about the standard unit itself, every standard unit will have a clear definition, because it must be what? It must be consistent, it must be invariable, it must be reproducible, and also easy to use. Only when you define it in a standard manner, right, it can be used, it can be reproduced, or it can be made to be consistent. Okay. Now how do we get the units of the derived quantities? It is not only the approach for the SI system, but for all the systems, any system, whether you take the FPS system or CGS or MKS, whatever system you take. How are we going to get the units of the derived physical quantities? The units of the derived physical quantities will be obtained from the units of the fundamental physical quantities. Okay. So how do we get the units of the derived quantities? We will get the derived quantities or the units from the units of the fundamental quantities. How do we get it? We will get it based upon the definition, or we will get it based upon the relation. Here, when we say derived quantities, like first class itself I told you, right, the list is starting now, and the list will continue till the last chapter that we are going to see in 12th. So it is not like our study of derived quantities is going to stop. It is starting now and continue till the end of 12th. So which means every new chapter we are going to get some new derived quantity. So what we'll do now is we will look at some common physical quantities, derived quantities. அதோட SI units எப்படி வருதுன்னு சொல்லிட்டு we'll just look at it. Based upon the approach, we can apply a same kind of approach and find the SI unit of any new derived quantities. Like as we go to the next chapter, we will see some more derived quantities. Another chapter comes, we will see some more derived quantities. Ella chapter we are going to see some new derived quantities. Whenever we see a new derived quantity, right, the first question I am going to ask will be, what is the SI unit of this particular physical quantities? So you will be able to apply the same approach and get the answer and tell me. Okay, so we'll start with this, guys. And first we'll start with the SI unit of velocity or speed. What is the speed definition? Speed is what? Distance by time, right? Means what? Distance is measured in length. Length or SI unit and a meter. Divided by time, SI unit is what? Second. So what is the SI unit of speed or velocity going to come? It will be coming as what? Meters per second. Velocity, how velocity becomes meter per second? What is the velocity definition? It is the displacement by the time taken. What is the velocity definition? Displacement by time taken, correct? So displacement means what? Shortest distance. So that is also what? Length only. Again same, length by time. So both speed and velocity will have what is the SI unit of both speed and velocity? It is meters per second. Okay va? Then we will look at what is the SI unit of acceleration. Acceleration in another, what is the acceleration? It is the change in velocity divided by time taken. Change in velocity means what? What will be the unit of change in velocity? Meter per second dana. Change in velocity means what? It will be also having the same unit as velocity, meter per second. Divided by K and the time. So what you are going to get? Meter per second square. The second, another second is there in the denominator. Meter per second square. This, see, we can write it like this also. Meter second power minus 2. Velocity also, we can write it like this. Meter second power minus 1. The denominator, we can just take it to the numerator. The power becomes what? Negative. Okay. Then comes momentum. Other than a momentum. Okay. See, these physical quantities, right? Derived physical quantities, we use some symbols for representing them. Some of them already we know. We use V as symbol for what? Velocity or speed. We use A as symbol for what? Acceleration. We use P as symbol for the momentum. Okay va? So momentum and another mass into velocity. Okay. So momentum is what? Mass into velocity. Don't worry about these things, because when we go to the respective chapter, so we'll go to Newton's laws of motion, and the chapter we'll talk about the momentum. Momentum or definition in a mass into velocity. Mass, what is the SI unit of mass? Kg into velocity in the meter per second. Check this, students. We'll put like a bar like this thing. When we put a bar, it means what? Into. So we will not usually put this into symbol. Between the units, you will not see people putting into. What they will put? Bar. Don't think the bar is something else. Another bar means what? That is basically into. Instead of writing kg into meter divided by second, right? We can also write it like what? Kg bar meter per second. Okay. Then force. Okay, I'll come to impulse later, but look at force. What is force? If you have an object, the force acting on the object will be equal to what? Mass into acceleration of the object. Force acting on the object will be equal to what? Mass into and the object would acceleration. So mass, what is the SI unit of mass? Kg. Already acceleration we derive pannirkom. Enadhi meter per second square. Okay va? So what is it? Kg meter per second square. But this unit of force, right, is in honor of Newton. It is also named as what? Newton. So we will not be saying kg meter per second square. We will rather say what? See, we should be calling it as what? Kg meter second square. But we will not be using this one. What we will represent is what? We will represent this as Newton. And the symbol for this is what? Capital N. This is named in honor of the scientist Newton, who has contributed a lot for the force and laws of forces. Okay va? But otherwise, what is a Newton actually? Newton and what is a Newton? Newton is nothing but kg into meter per second square. Clear, student? What is a Newton? Newton is nothing but kg into meter per second square. Okay. So this is in honor of the scientist who has worked in this field. This is also called as what? Newton. Okay. Now let us go to the impulse. We left impulse before. So now we come to impulse. Impulse, we will look at the definition of impulse again in the same chapter. Newton's laws of motion. Okay. So impulse is measured as force into, so say for example, there is a force acting on the object for some time. So impulse is measured as what? Force into time for which the force is acting. How do you measure the impulse? Impulse on a body is measured as what? Force into time for which the force is acting on the body. So on the definition based panni enna varum, look at this. What will be impulse? Force means what? Kg meter per second square into time is what? Second. So enna varum? Kg, 1 second will be cancelled. Okay. What is it going to be? Kg meter per second. Enna varudhu, it will be coming as what? Kg meter per second. Otherwise we can also write it like what? What is the force or the unit? Newton, right? We can write it as what? Newton into second. Either we can write this as what? Kg into meter per second. Illana we can write it as what? Newton into seconds. Okay. Then pressure. So I'll rub this space so that we can use it. So this is a continuous process, students. Like every new chapter we will go to write, we are going to get some new derived quantity. Then we will have to find out what is the SI unit of that new derived quantity. Okay, va? So it's a continuous process. So we have covered up to the pressure, and some of these SI unit values, right, they are named in honor of the respective scientist who has contributed for the particular field. Like we already covered one. What is it? Force or SI unit. It is named after the scientist Newton. Then other than pressure. See, pressure is defined as what? Pressure is defined as force divided by the area. Area whatever the force acting on the area, right? Force divided by the area. If you have an area, there is a force acting on the area. So how do you measure the pressure? Pressure will be defined as what? Force divided by the area. So force means what? Already we have, right? Kg meter per second square. Area means what? Meter square. What is the SI unit of area? Meter square. Because area will be what? Length into breadth. Length is also distance, breadth is also distance. It will be what? Distance square, means it will be meter square. So we can see either we can use it like this, or we can express force as what? Newton. So if I express force as Newton, means what will be the pressure or the SI unit? It will be what? Newton per meter square. It will be what? Newton per meter square. Per means what? So when you have the quantity in the denominator, right, we will use this as what? Per. Okay. So Newton per meter square is also in honor of the scientist Pascal. When we go to the chapter, we will have a chapter called as Properties of Fluids. 11th level, we will get the chapter in 11th standard. Okay. So in the Properties of Fluid chapter, we will talk about Pascal's law, which is a very important law with regard to pressure calculations. Okay, va? So in honor of the Pascal, right, this is given the name Pascal, and the symbol for this is symbol in the it will be capital P small a. What is symbol for the Pascal? It is capital P small a. Arthadi kinetic energy, potential energy, I mean all the energies, they are all the same. Like in the last class we said, right, hydraulic pressure, okay, gas pressure, all of them are what? Pressure only. So all energies will have the same unit. What is the unit? We are naming it as joule. What is the unit named as? It is named as what? Joule. So the energy and work, right, they will be having the same units. So energy and work, they both will be having the same units. Okay. So what is this work or energy? How do you measure work? So in the second chapter we will discuss about how do we measure work. So before that, right, let's just take the basic definition. So work got a basic definition. What is the basic definition of work? So here we will just take it as force into displacement. But it is not this simple. We'll have another definition of work. We'll see that when we go to the respective chapter. In Enedikala, we can take it as what? Force into displacement. Okay. Actually, it should be force into displacement of the object in the direction of force. What is it? It is what? Force in displacement of the object in the direction of force. But what is it? Force means what? Newton into displacement and meter dana. But this is named, both the SI unit of energy and work is same. Is named after the scientist Joule, because Joule has contributed a lot for the thermodynamic studies. Okay, in fact, when we go to thermodynamics chapter, we will see the laws proposed by the scientist Joule. So the SI unit of energy and work is named after the scientist Joule, and the symbol for this is what? Capital G. What is symbol for this? It is capital G. Okay. Next, we have power. So power is what? Power is if you have any engine, right? So we will define the power of the engine is what? Work done by time taken. How do you define the power of the engine? It is defined as what? Work done by time taken. Okay. So work done means what? It is Joule. By time is what? Second. So we have to have it as what? Joule per second. But it is in honor of the scientist Watt. It is given the name WATT. And what is symbol for this? Capital W. What is the symbol for the SI unit of power? It is capital W. Okay. I think some of these things we are already aware of it, but I am still continuing so that you guys know what is the procedure. So what is the procedure? If you see all these things right, you can probably type it over there in the chat box also and tell me what is the approach we are doing. We are basically looking at one equation where this particular derived quantity is related to the other known quantities. Pressure in the equation, just look at this equation. We have pressure. Pressure is the unknown quantity. How are we getting the pressure of SI unit? Because we are saying pressure is equal to what? Force by area. If we know the SI unit of force and you know the SI unit of area, we can find what is the SI unit of the pressure. So whenever we are finding the SI unit, we require what? One equation where this particular quantity is actually appearing. Okay, va? Then we'll come to the last one. What is it? Density. What is density? Mass by volume, Dana. What is density? Mass by volume. What is the mass SI unit? Kg. What is the volume SI unit? Meter cube. How it comes meter cube? Because if you take a cube, what is the volume of the cube? Length cube, right? So length into length into length. Length and the distance. It's what basically what SI unit of length is meter. So meter into meter into meter, it will be what? Meter cube. So the SI unit of volume is what? It will be meter cube. So density and the density will be what? Kg per meter cube. Clear? So these are the SI units of the derived quantities, and this is not the derived quantities full list. This is just one very small sample. In fact, all these things, right, we will be covering in the first or the next two chapters. But discuss all quantities, right? We will be covering them in the third chapter and fourth chapter. We will complete all these things. So we are going to learn even more variety of derived physical quantities. Why we discussed about only these things is we have some familiarity with these quantities. Okay, but students, now what I will do is I will also upload a recorded video on lot of other derived quantities and how we will get the SI units of those derived quantities, because as I said, there are around 100 of them. We can't keep on we will do it when we go to the respective chapter, but there is no point in doing all of them in the first chapter itself. So what I'll do is I'll upload one recorded lecture on that. You can just go through it. Okay, so it's not like you have to just simply go through it now. If you are interested, you can go through it. Okay, but it will be always good to learn something extra. But anyway, when we go to the respective chapter and the chapter we will cover that. Okay, so this is the procedure, students. This is how we are going to get the SI units of the derived quantities. Now there are some of these rules, special rules and special rules. Okay, So these special rules, right, are proposed for writing the SI units. But the thing is, at least at some point of time in the board exam and all that, if you are not following these rules, people used to cut marks. But nowadays, these rules are not given. It's not like, these rules are not given so much importance on the madri kadiyadu. It says that, even if you are not strictly following these rules, you will not be penalized for that. Okay. But it is good to know what are these rules. So look at these rules. These are the rules that we need to follow while writing the SI units. Some of these units, right, like we have seen, are represented by the names of the scientist in honor of the respective field. So all these units, right, their starting letters also will be small. Newton, we got one. Joule, watt, we also have Pascal, ampere, Kelvin. All these units are coming after what? The respective scientist. So for all of them, right, the full unit name, when you're writing the full unit name, we should write this in the small case, lower case, including the initial letter. Means, if I want to talk about a force, I should write it like this, 5 Newton. I should not write this like 5 Newton, or I should not write this like 5 Newton. Okay, these two are wrong. But if you're asking, sir, if I write it like this, are they going to cut marks? Means no. Okay, but these are the rules that we need to know, that how they have been proposed. But if you are strictly not following these rules, you may not get penalized now. Okay, next look at the second thing. The symbol of unit named after a scientist is always given in the capital letter. Like I've been telling, what is symbol of Newton, capital N? What is symbol of power, capital W? What is symbol of the pressure, capital P, small a, Pascal? What is symbol of the SI unit of current, ampere, capital A? What is symbol of SI unit of thermodynamic temperature, Kelvin? Symbol is what? Capital K. All these symbols will be what? Capitals. Okay. Now the other thing is the punctuations like full stop or comma, right? They will not be used after the symbol of the unit. Like we will not generally put like 5 Newton dot, like that we will not keep. Just after the unit we will not keep any dot. Then the unit should be always represented in the singular form. So this is a very common mistake that we do. Okay, so if we get 10 seconds, right, I'm sure a lot of us make this mistake. So we have seen people putting 10 seconds. If you want to write 5 kg, right, so instead of writing 5 kg, what most of the people do is they will write it like this, 5 kgs. But the thing is, always the SI unit, right, we are not required to express this in the plural form. It's enough if you write it as 5 kg. You are basically saying there is something called as a kg. There is a unit value called as what? Kg. Now, our measurement, let's say for example, the mass of a rice bag is 5 kg. What it basically means is, the mass of the rice bag in our hands, right, is 5 times of the kg unit. And the kg unit of value, it is what? 5 times. So we don't need to express the plural. So it's okay if we just write it as what? Singular form. So these are the rules. Maybe, it's good to know, but as I said, we will not be penalized for going wrong on these things. So just know, so that you will not get panicked in terms of the okay. Clear, students? Now let's go into the next important segment, which is where we need to be careful. Okay, so it's not like we are going to get questions on this, but we will be required to do this in most of the numerical problems. A lot of numerical problems that we solve in physics, right? We will be doing this. What is this? This is the conversion. As I said, right, somebody is giving the value of the mass in pound and we have to convert this into what? A gram. So we should know how do we relate gram and pound. Then only we can do the conversion. So if you look at these units, right, the standard units, there are a variety of them. These units, they are either related by using a prefix concept, or they don't have any prefix relation. If they don't have any prefix relation, right, then we should go to the definitions of these quantities and then relate them. Clear, students? So if you look at these physical quantities, other units, right, some of them you will have the prefix relations. I'll tell you what you mean by the prefix relation, but just think about it. Some of them will have the prefix relation, and if you are not having prefix relation means, then you have to go to the definitions of these quantities and then relate them. What do you mean by these two, prefix and definition based? Okay, see, if you have the unit meter, okay, then when you see these things, right, a centimeter, a millimeter, a kilometer, what are we actually doing? We are putting a prefix. Okay, now what happens by having a prefix is the value of the unit, right, can be either enhanced or it can be decreased. Each of these prefixes has got one accepted multiplier value. Each of the prefixes, right, has got one accepted multiplier value. Another, like say for example, we will see the list, okay, but on the prefix base panni you will have certain units related. Like now we can see meter and kilometer, right, how they are related by using prefix. Meter and centimeter, how they are related by using the prefix. Meter and millimeter, how they are related by using the prefix. Clear? So we will have the prefix based relations between these units. And if we look at, say for example, a meter and a foot, these two you don't have any prefix relation, then we should go to the definition of a meter, we should go to the definition of a feet or foot, and then, because already I said feet is a plural form, foot is a singular form, but again you can use it, not a problem. Okay, so we have to go to the definitions of these two and then relate them. Okay students, so this is how we will get the relations between the units. Either we have the prefix relations, illana we are having what? If you don't have a prefix relation, we should go to the definitions of these quantities, and then only we will be able to relate them. Clear? Now what we will do is, we will look at, I am going to show you a couple of tables. We have to copy these tables, students, because these tables we are going to use. Now this list, right, is a list of prefixes, that will enhance the value. So if you see the power multiplier, right, all multiplier values paatha enadi 10 power 1, 10 power 2, 10 power 3, 10 power 6, 10 power 9, 10 power 12, 10 power 15, 10 power 18. You are enhancing the value of the unit. Okay, first another deca. Deca na, we also can represent this by the symbol DA. Okay, va? So deca means what? 10 power 1. So if we say decameter, so if we say 1 decameter, decameter means what? It will be 10 power 1 times of meter. All that. That's how the multiplier comes. What is 1 decameter means? 10 power 1 meter. Okay, va? Then hecto. What is symbol for this? H. Hecto means what? 10 power 2. Students, you can copy this while we are discussing. Other than a kilo. Kilo we know it. What is kilo? 10 power 3. Mega. Mega. Look at the symbol for mega. What is symbol for mega? Capital M varum. What is symbol for mega? Capital M. Okay. So why I am saying capital M is because there will be small m for another prefix. Okay. Small m will come in the prefixes, that will decrease the value. Okay. So mega means what? 10 power 6. Artha the giga. Giga, what is symbol for giga? Capital G. Giga another 10 power 9. Giga means what? 10 power 9. Artha the tera. Tera, what is symbol? Capital T. Tera means what? 10 power 12 varum. Tera means what? It will be 10 power 12. Okay, va? Then next is what? Peta. Peta, what is symbol for peta? Capital P varum. Symbol for peta is what? Capital P. Peta means what? 10 to the power of 15 varum. Other than exa. Exa, what is symbol for exa? Capital E. What is it? 10 power 18. So if you say, I think you know this kilo, mega, giga, tera, all these things we will be using in terms of our data or memory. Like you know, if you see the hard disk memory, right, they will say 1 TB hard disk, 2 TB hard disk, like that. So what is tera means? 10 power 12. If you look at our internet, they will say you can use up to 1 GB per day, like that. Giga means what? 10 power 9. And mega means what? 10 power 6. Normally your internet speed will be in the range of megabytes. Okay, so kilo means what? 10 power 3. Okay students, so these are the prefixes used to increase the value. Now let us see the other side of the story. The prefixes used to decrease the value. So what are these prefixes? Starting from deci. Deci means what? If you say 1 decimeter, what is 1 decimeter means? It is what? What is the prefix value for deci? 10 power minus 1 into meter. Otherwise we can write as what? 1 by 10th of a meter. What is a decimeter means? 1 by 10th of a meter. Okay students. And centi means what? 10 power minus 2 means if you are saying 1 centimeter, right? What is 1 centimeter means? 10 power minus 2 times of a meter. We can write this as what? 10 power minus 2 means 1 by 10 square, right? 10 power minus 2 means what? 1 by 10 square, no? It will be what? 1 by 100. So 1 by 100 of a meter. So 1 centimeter is equal to what? 1 by 100 of a meter. Otherwise, if you bring the 100 to this side means 100 centimeter is equal to what? 1 meter. 100 centimeter is equal to what? 1 meter. Okay. Then milli. What is milli? Milli means 10 power minus 3. What is milli means? Milli means 10 power minus 3. That is the prefix milli. So milli, what is the symbol for milli? Small m. Remember I said capital M is for what? Mega, 10 power 6. Milli is what? 10 power minus 3. Then the micro symbol, look at this word. How do you spell it as? We will spell it as mu. So if you say 1 mu m, mu represents what? Micro. Micro means what? 10 power minus 6. See, microwaves. We hear about the microwaves. Microwaves, right? Generally for a wave, we will be talking about the wavelength. So waves will have two important properties, right? The wavelength as well as frequency. Microwaves will have their wavelength in the range of micrometer. Adukada we call them as what? Microwaves. Okay. So micrometer. Micrometer is 10 power minus 6 varum. Prefix oda value. Other than nano. We keep hearing this word. Nanoparticle, nanotechnology and solid. Okay. So what is nano means? Nano is 10 power minus 9. Symbol is what? N. Small n. Okay va? And you can see all these are what? Small varum. Symbols ella. Adula we have capitals. So pico means what? 10 power minus 12. Generally, right? The size of the atom and molecules. Atom and molecules or size, it will be in the range of what? Nanometer and the picometer. Picometer means what? 10 power minus 12. Pico means what? 10 power minus 12. What is the pico means? 10 power minus 12. Okay, va? After the femto. Femto, what is the symbol for this F? It's the size of nucleus, right? So in chemistry, you will be learning about it. Nucleus, atom nucleus will be there, right? So size of the nucleus will be in the range of femtometer. Femto means what? 10 power minus 15. Other than auto. Auto is 10 power minus 18. Auto is what? 10 power minus 18. Then we also have other prefixes. Okay, after we will get 10 power minus 21, etc, etc. Okay, but we will be not much encountering those things. We will just look at up to maximum femto. Why? Because we will cover only up to the femto part. Okay, so look at these guys. These are what? These are the prefixes. These are the prefixes that will decrease the value. So we have prefixes that will increase the value and we have prefixes that will decrease the value. Okay, clear students? Now we'll just take a look at this question. Look at this students, guys. What is the question? What is the question? Arrange them in the increasing order of the value. எப்படி நம்ம arrange பண்ணணும்? We have to arrange them in the increasing order of the value. என்னென்ன கொடுத்திருக்காங்க? Look at this. What are they given? They have given us what? What they have given us? Mu m. Mu means what? Micro. Mu means what? Micro, right? Micro means what? 10 power minus 6. Micrometer means what? 10 power minus 6 meter. Arthana mm. Mm means what? Millimeter. Milli means what? 10 power minus 3 meter. Arthana picometer. Picometer means what? 10 power minus 12. Next is what? FM. F means what? Femto, right? Femto means what, students? 10 power minus 15. Arthana kilometer. Kilometer means what? 10 power 3 meter. Kilometer means what? 10 power 3 meter. Adana. So we have to arrange them in the increasing order. Increasing order and the from smallest to highest, right? Other than increasing order. Look at this, guys. So this is what? The micro. This is what? Milli. This is the pico. This is the femto. And this is the kilo. So what is the increasing order? Which is the least? 10 power minus 15 is the least, right? When the power of 10 is maximum negative, that will be least value, correct? So means what will be the increasing order? Femtometer 10 power minus 15 will be the least. Other than picometer. Okay, students. Next will be what? Other than the micrometer. Okay. Other than millimeter. Next will be what? Kilometer. Okay. So this is what is the order. This is what is the correct order. Students, you know, you have to type the answers over there. I'll be checking. Type it over there, students. Okay, I'm yet to see the responses. Okay, so I think this much you may have got this correct. Okay, but anyway, check it up. So this is the order of the comparison. Okay.